My name's Nick with Pure Water Systems of Nevada. We've got a customer who had some high levels of bacteria in their well, not an uncommon problem. And so our solution for them in this instance was to do a chlorine injection system with a contact tank or retention tank, and then an iron breaker after that injection system. And I'll explain why we do all of that here. So we're injecting the chlorine, obviously, to then be able to kill any of the bacteria, but we don't want any of that residual chlorine to make its way into the house. One of the joys of well water is that it's not chlorinated. So by running it through a tank that has some carbon in it, we're pulling out not only any of the iron that happens to make its way through, but also any of the chlorine that's remaining in the water, so that any water going to the house is all completely chlorine-free and iron-free and bacteria-free. To do this, we bring water in from the well, and before the pressure tank, we have our flow switch. This flow switch right here is just an on-off type signal that it sends to our chlorine pump. The reason we do it in front of the pressure tank is because the well is always going to pump at a consistent rate, whereas after the pressure tank, the rate is variable. If somebody has one faucet on or 5 faucets on or a shower or whatever. So we've got our flow switch that tells our chemical pump to pump. And then just after that, because water is moving this way, we have our chlorine injection site. And then we go into the pressure tank. And then from the pressure tank, we go into the retention tank. And having both of these gives us enough contact time where the water is actually in contact with the chlorine solution to give it time to kill any bacteria, give it time to oxidize any iron that's in the water, and separate that stuff out. This retention tank has a distributor tube down the center of it, like most normal tanks do, but the distributor tube stops at about this level, which allows this part of the tank and water column to collect any sediment or dead bacteria or anything that's been oxidized to then be dissolved out of solution, or sorry, brought out of solution into a solid that can then sink down. So it gives us plenty of time to interact with the bacteria here, and then we come into through our sediment filter, which is just giving us an indication that no sediment is making its way through the retention tank, and go from there into our iron breaker. Iron breakers are great for removing smells and odors, as well as iron, as well as chlorine. The carbon and the filter ag that they have inside work together to remove all of those things really well. And so then we also have our test port at the very end here so that we can test the water coming out of the iron breaker to make sure that it doesn't have any chlorine in it. We can also use this test port by putting the bypass into bypass to test the level of chlorine coming out of the tank as well. The Stenner pump is our chlorine injection pump, and like I said, it is wired to our flow switch on the incoming water. And we spent some time today figuring out how best to set their percentage of speed of this pump. That's all that the percentage is. The percentage doesn't change the amount per pump. It just changes how fast the wheel rotates, so how often it pumps. For heavy iron and heavy bacteria injection solutions, we typically start around 35% speed. For mostly just bacteria, we can start at about 10% speed and then with testing can figure out exactly what speed we need to be at to make sure that we've got somewhere between about half a part and 2 parts per million coming out of the tank before the iron breaker. The iron breaker is easily able to remove that and more, but its carbon will last longest if we're in that 0.5 to 2 range. So as you can see inside the chem tank here, we're sucking our solution up through that black sediment pre-filter in the bottom, through our tubing. Our little wheel is spinning this way, which sucks and then pushes the solution farther down the tube. And this tube runs behind both of these tanks to our chlorine injection site after our flow switch. So for wiring a Stenner pump to a Stenner flow switch, we have the flow switch plumbed in before the pressure tank so that we have a constant rate of flow through that flow switch. On the flow switch side, we have brown and blue wires. On the Stenner pump side, we have red and black wires. It does not matter what you hook to what. We'll go red to blue because, again, it does not matter. Wire nut. Nice and snug.
Green to black.
Wire nut. And we're wired. Tank's now in bypass, so we can get an accurate reading out of our test port of what the chlorine coming out of here is. I'm just waiting for our Stenner pump to stop spinning as the well stops filling these two guys back up. And then we'll be able to run some water and test our chlorine. Just like so.
We run some water through the test port on the back of the iron breaker to clear out the water that was already sitting in the bypass valve. We then run our chlorine test strips under the water for about 30 seconds. Compared to our test bottle, we can see that we are still high on chlorine. We want between 0.5 and 2 parts. So next, Nick is going to reprogram the Stenner pump for a slower injection of chemicals over time.
And you'll see that at the very bottom, or in our case the top, of the screen here, it will say keypad locked. And so to unlock your keypad so you can make changes, you're going to push and hold the mode and the percent signs for about 5 seconds. And you'll see the keypad locked stops flashing and the light lights up on the screen a little bit brighter. Now to change our mode, if we were going to be having it go off of a relay that was different than the flow switch or some other metering signal, you can hold mode and your up and down arrows will take you through the different mode and settings options. We want to be on flow switch. We just tried at 35%. I think that's going to be a little bit high, so we're going to go down to like 25% because we were testing still decently high. Just by letting go, it will eventually in 15 seconds or so relock itself so that those settings get saved and can't be changed.
We then went back and forth between testing the water for chlorine and reprogramming the Stenner pump. With too much chlorine, we reprogrammed the Stenner pump for a lower speed. With too little chlorine, we would reprogram the Stenner pump for a higher speed. In this instance, since there was very little iron in the well, we found that 10% speed was actually perfect. With the iron breaker bypassed, we would get around 1.5 or 2 parts per million of chlorine, but with the system in service, we were getting 0, meaning we had found an effective speed for our Stenner pump. All in all, this chemical injection system is designed to introduce chlorine for the oxidization of organics and bioorganics into the water supply. Due to its relationship with the retention tank, it aids in the removal and collection of sediment, now dead bacteria, ferric iron, and other suspended particles. With a sedimmaster and an iron breaker in place afterwards, further bleed through of sediment may be monitored, and all excess chlorine and iron will be collected by the iron breaker before it enters the home for day-to-day use.